Today we're going to start learning about select statements, and I'm going to start by opening SQL Server Management Studio, which is under Microsoft SQL Server Tools 17. And I'm going to connect to the database cisdbss.pcc.edu using SQL Server Authentication, and I'm going to use 275 student as the login, and the password is also 275 student, and I'm going to connect. So the book has in chapter 3 has examples of SQL select statements, and it's using a database called AP. And if we go ahead and open the databases tab and open AP. So here are the tables in the AP database. And I'm going to start in a query window. And let's go ahead and save this as, under Documents, I'm going to save this as Week 1 Select. .SQL. And then the first line I'm going to include is use AP. So now it's going to be using the database that the book was using for its examples, and I'll start with an example from the book. So select star from invoices. And throughout this class, I'm going to be using all uppercase for the SQL keywords. We're using table names however they appear in the database. So this matches how it appears in the database. And I'm also going to be using column names the same way they appear in the database as well. So let's go ahead and hit execute. And we see the same results as we see in the book. And then in addition to, so this star here, this is a special wildcard character for column names, and it basically means include all of the column names. So if we go ahead and look at the columns, we see that there's actually in the invoices table, the columns we have available are invoice ID, vendor ID, invoice number, invoice date, invoice total, and so on. And those match the columns that we have coming back from our query. Now you can also specify a subset of columns. For example, select invoice ID, vendor ID, and invoice date from invoices. And if I execute this query, I get back just those three columns. So for example, if a question is asking you for the invoice total, credit total, and payment total from the invoices table, then I would go ahead and select invoice total, payment total, and credit total from invoices. And here's that query. Now in the homework file, you're going to see Go statements mixed in with the places where you write your code. And what this is doing is it's creating a batch. So between the goes, basically it gathers up all the SQL statements between the goes, and then when it hits the go, it executes that block of statements. And if there's an error anywhere in that block of statements, the whole batch is terminated. The reason that we do that is so that if you get an error in one of your queries, for example, I'm going to put in a bogus field name. And if I execute this whole SQL file, I get an error, but it executes everything in this batch and everything in that batch. So if I look at my results, I got back the results from the first query, and I get back the results from the last query, I didn't get anything back from the middle, but I did get this error message. So if you're working on multiple problems, you can use these go statements to create batches so that all of your other queries will get executed even if one of them has an error. But be sure to check your messages and find and fix any errors that you have before submitting your lab. So moving on, in addition to listing columns, you can also put just regular values. And you don't even need this from statement. So I'm going to start with select 3 just by itself. And if I execute this, I just get back the number 3 as one column. You can also use calculations that are based on operations, both mathematical and string operations. So select 2 plus 2, and we get back 4. Now I can also use string operations here. So select quote plus word plus quote. What this is going to do is it's going to take the literal character string double quote, the word, the literal character string double quote, and glue them all together into one piece of text. Like so. Now you'll notice that in SQL we're using single quotes for character string literals, pieces of text. Double quotes are used for column names, and we'll see that in a minute. Now there's also some functions that you can use that are built into the language. For example, if I do select plus and then put some spaces plus that, and if I execute that, you see I have a double quote and then some spaces, the word, and then some more spaces followed by a double quote. I can also add some functions. For example, here's an rtrim function that trims white space off of the right side of a piece of text. So this is going to trim all of the spaces on the right of word, which I think this is the right. So you'll see double quote, some spaces, word, and then a double quote. Right? So it takes this value, executes rtrim on it, then concatenates the double quotes on the end. There's also an ltrim. Actually, let me just do this. ltrim, which trims white space off the left, like so. So now I've trimmed the space off the left, but not the right. You can also pass the results of ltrim into rtrim, like so. And this will trim the white space from both the left and the right before adding the double quotes. Now when I execute these commands, I'm getting back a single value. But I can also apply these commands to values that are in the column of a table. So for example, let's go back and select star from invoices again. And we'll execute that. And now, what if I want to know the invoice total plus the payment total plus the credit total for each of these rows? Well, I can do that. And now I'm going to get back, actually let me select invoice ID, vendor ID. Capitalize that so it matches the database. If I execute this, I get back 2 columns with the actual column values in them, and I have an additional column which is a calculation. So this column plus that column plus that column. Now you'll notice that there's no column name here for any of these calculated values. There's nothing for a column name here. There's nothing for a column name here. Same thing here. But it's good practice and often required to actually put a column name here. And the way you do that is you can add as right after any column and then the name of the column. So the first thing I'm going to do is I'm going to reformat this so that it's a little easier to read, because this line is starting to get long. So I'm going to go ahead and break that line and tab, and I'll tab that over as well so that everything lines up nicely. Do the same thing with invoices. And now I can add as, and then I'm giving it not a character string literal, but an identifier. So the difference is an identifier is the name of a column. A character string literal is just a piece of text. And according to the language spec, this wants an identifier. So I use double quotes for the column name. So this is going to be the total. And let's also use double quotes for this column name, vendor ID. And let's also rename this column. So now if I execute this, you see that all of the column names have been renamed based on what I used in the as. Now, if you're doing a name that's legal as a column name with no special characters or spaces, these double quotes are optional. So if I do this, it's going to do exactly the same thing. That's not going to work up here because of that space. So if I try to do this, now I'm going to get an error. And you can see with the red curlies that it's already, syntax highlighting is already warning me that I have incorrect syntax near ID. So if I go ahead and put the double quotes back in here, now it's going to work. I'm always going to use double quotes in these videos, but Microsoft SQL Server will accept a couple of other different punctuation for that. One thing that SQL Server allows is use of square brackets, and you'll see that in some examples online where people are working with SQL Server. Works exactly the same as double quotes. Another thing that you'll see online is people using single quotes, which, as I said before, are character string literals. But if I execute it, SQL Server will treat it exactly the same. The reason that I prefer to use double quotes here and recommend that you do as well is because double quotes are part of the SQL 92 spec on the language and are widely supported across different databases, while square brackets are only supported by Microsoft SQL Server, and single quotes are supported by some but not all other databases. So if you want to be as portable as possible, meaning it's easy to switch to other databases later on, either with your code or just what's going to come out of your fingertips when you're typing, double quotes are really the best choice here.